Hello! Welcome to today's lesson on tidal energy. Today, we will start by understanding what tidal energy is and how it is used. We will then evaluate the reliability and renewability of tidal energy. Finally, we will examine the environmental impact of tidal energy. So far, we have evaluated various renewable and non-renewable energy resources. Now moving on to tidal energy. Let's get started. Tidal energy is a type of renewable energy that originates from the natural rise and fall of ocean water levels, known as tides. Tides are generated primarily due to the gravitational pull of the moon and the sun on the Earth's oceans. This gravitational interaction causes water levels to rise and fall in a predictable, cyclical manner along coastlines around the world. Tidal energy can be harnessed in a few different ways, but one common method involves the use of tidal barrages. A tidal barrage is similar to a dam, but is specifically built across the mouths of estuaries or bays, where the difference in height between high tide and low tide, or what we refer to as the tidal range, is significant. As the tide comes in, gates in the barrage are opened, allowing water to flow into the estuary and become trapped behind the structure. When the tide begins to go out, a different set of gates opens, releasing the trapped water. As the water flows back out to sea, it drives turbines connected to generators, which then produce electricity. This process effectively converts the kinetic and potential energy of the water into electrical energy that can be supplied to homes and businesses. Tidal energy currently contributes only a small fraction of the UK's total energy production, less than 0.1%. However, the potential for tidal energy is significant. It is estimated that if tidal energy were fully harnessed, it could meet up to 10% of the UK's electricity demand. A tidal barrage across the Severn estuary alone could generate around 5% of the UK's total electricity needs, enough to power over 3 million homes. This highlights the incredible potential that tidal energy holds for the future. Tidal energy is generally considered very reliable compared to some other forms of renewable energy. This reliability stems from the predictability of the tides. Unlike solar or wind energy, which can be variable and depend on weather conditions, the cycle of the tides is consistent and can be accurately predicted years in advance. However, it is important to note that tidal energy is not constant. It is only available when the tide is moving, so there are periods during the day when tidal flow is insufficient to generate energy. This means that while tidal energy is reliable in the sense that it is predictable, it needs to be complemented by other sources of energy or storage solutions to provide a continuous power supply. Because this energy comes from the natural, ongoing movement of seawater, it is classified as a renewable resource. The continuous motion of the tides is driven by the gravitational pull of the moon and the sun, which are constant forces. As long as these celestial bodies exist and maintain their gravitational effects on Earth's oceans, tidal energy will be available as a resource. This makes it a sustainable option for long-term energy production. So what is the environmental impact of tidal energy? Tidal energy projects, particularly those involving tidal barrages, have a lower environmental impact compared to fossil fuels, but are not without their challenges. One of the major benefits is that tidal energy harnessing produces minimal greenhouse gas emissions and pollution, making it a cleaner alternative to fossil fuel-based energy sources. However, constructing tidal barrages can significantly disrupt the natural flow of water and sediment. This disruption can negatively affect marine ecosystems, including fish and other aquatic organisms that rely on tidal cycles for breeding, feeding, and migration. Furthermore, these constructions can also impact the movement of materials like sand and silt in the water, which might lead to changes in the shape and structure of the coastline. This can lead to parts of the coastline or seabed slowly breaking down and wearing away over time. While tidal energy is generally considered environmentally friendly compared to traditional energy sources, these potential impacts must be carefully managed through thoughtful design and planning to minimize harm to marine life and ecosystems. In today's lesson, we examine tidal energy as a form of energy. We learned that tidal energy is produced by harnessing the movement of tides, which are influenced by the gravitational pull of the moon and the sun, and discussed how tidal energy can be captured using tidal barrages. We also explored its reliability and status as a renewable energy source. Lastly, we considered the environmental impacts of tidal energy. While it produces no greenhouse gas emissions, tidal energy installations can disrupt marine ecosystems and affect local wildlife.